Hi grade 12s. I'm going to put together a few videos on paper 2. If you want to work through them on your own, of course, or with the mark scheme, if you find that more useful, please do. There's not really a lot of things that I need to talk about with it. It's just a few questions that I need to go through. But first things, I guess if I talk about the things that I want everyone to hear about, then those of you that don't want to watch videos can skip the rest of it. Question 1 was not done terribly well. I think it's a bit of a tough question actually, and it's partly to do with the diagram, and also partly to do with the shape that they give you at the top of this page. It makes you think that this is one of the trapezia that form the sides of the reservoir, when in actual fact it's this trapezium in the middle, and they are slightly different dimensions, and that caught a lot of you out for the surface area question at the end. So that's one thing to look out for. Question 2 was pretty good, well done. Seemed to be a topic that lots of you were pretty confident with. Question 3 was also done quite well. Just be careful. In maths, unless it's finance, you should be giving your answers to 3 significant figures, not decimal places or anything like that, always 3 significant figures. That was a bit of an issue for some of you in this question. Question 4 is one that I will go through. You've got to use the formula guide for these matrix questions. Pretty much every single transformation you can do, that we do, linear transformations, are in the formula guide. So if you didn't use it, it's really difficult to use. Those of you that did still struggled a bit with the reflection. So that's the main one I want to look at with that question. Question 5 was done really badly. I think we need to take a look at complex numbers at some point in the next week or two. You certainly need to start doing some review on it. I feel like very few people got more than 1 mark on this question. So that's one that we definitely need to look at, and one that I will go through. Question 6 actually went pretty well. I was really pleased to see lots of you in part A, you're given that y is equal to the derivative of x dot, and lots of you wrote down that of course that means y dot is equal to x double dot, which was important for getting both the marks for part A. Lots of people, a few people struggled with coming up with the matrix A, but then it seemed like lots of you knew how to find eigenvalues, which is really great. Eigenvectors, you need to review how to do that. So yeah, I might look at one of the answers to C2 just as a reminder later on. And then question 7, this one wasn't done so well. These were the 2 kind of the toughest types of hypothesis test, in my opinion, because there's not a feature on the inference app that helps us. So question 7's another one that I'll go through. There aren't really any other general things to say. So if you want to work through these on your own, if you want to do your corrections independently or using the mark scheme, please feel free to, don't worry about listening to the rest of this video. I will start to go through the questions. I'll probably have to break it up into a few shorter videos, but we'll do that. So question 1, I don't think we need to do all of question 1. Lots of people were happy with the angle of depression and finding CV. Some people did it quite nicely using similar triangles or ratio. Others did it with trigonometry. And then you use the formula guide for the the volume of a pyramid for B part 2. And people were pretty confident with part C, which is also nice. Part D was the one that I said didn't go so well. So it says, to avoid water leaking into the ground, the 5 interior sides of the reservoir have been painted with a watertight material. Find the area that was painted. So for that, we've got to go back up to this diagram. The interior sides, we've got this square at the bottom. And then we've got these 4 trapezia that are all identical that go here. So we need to find, obviously, the area of one trapezium multiplied by 4, and then add on the area of a square. So, part D. So, 4 times area trapezium plus area square. Right, let's take a look at one of these trapezia. So they are 80 and 60 as their parallel sides. Let's have a little sketch. 80, 60, which is really similar to that one they've given you up there. And so that's why I can understand why people are confused. But if we think this is kind of like a vertical slice out of that pyramid, this height is going to be different to the slanted trapezium that we're talking about here. It's going to be a bit shorter. So we need to find this length down here. Let's colour it in purple. This is the length that we... no, not that length, sorry. We need to find this length, the distance between those parallel sides. Okay, so how do we find that? It's going to be the same, if we have a look at it, it's going to be the same as MN. That's the distance between the parallel sides, isn't it? So if we take a look at that, here is a diagram with MN on. I think you've already found the angle from M to N in part A. So you know this angle here. Lots of you split this shape up. So you said it's symmetrical. And if the whole top length is 80 and the bottom length is 60, then you know that this is 10 and this is 10. Oh, and we know this is 6 as well. Okay, so you can get MN through trigonometry or through Pythagoras theorem. I'm going to get it through Pythagoras theorem because I haven't got the answer to A to hand. So I would do 6 squared plus 10 squared and then square root it, of course. Okay, let's just get that. That's going to be the square root of 136, isn't it? Square root 10 squared plus 6 squared equals that. I think for now I might just write it as the square root of 136. So that, let's put it on here. Square root 136. Okay, so to get our area of our trapezium, it's in your formula guide, the formula for this. It is A plus B times H divided by 2. I want 4 trapezia, and then I want to add on the square. The area of the square, it's a 60 square, so it's 60 squared, and then we can calculate that to find our total surface area. We don't want a lid on the top. We don't want an 80 by 80 square, otherwise there's nowhere for the water to go in, is there? So yeah, we're going to assume that that's open. Okay,